so there's a background noise. Good morning, dear colleagues and guests. It's December the 3rd, 2020, 15 o'clock, 3 p.m., and we are beginning the panel session for the defense of the thesis by Pyae Sone Ko Ko. The thesis is submitted for the academic degree of the candidate of technical sciences. The specialization is 051311, mathematical and programming support of computers, complexes, and computer networks. The topic of the thesis is the construction and optimization of virtual distributed computing systems. Under the order issued by St. Petersburg State University as of September the 2nd, 2020, Andrei Peterhof, Doctor of Sciences in Physics and Mathematics, Professor, Head of the Department of System Programming of St. Petersburg State University, have been appointed the chairperson of this dissertation board. The order approved the candidacies of the members of the board, and let me introduce them. Alexander Degtyaryov, Doctor of Technical Sciences, Associate Professor, Professor of the Department of Computer Modeling and Multiprocessor Systems of St. Petersburg State University. The following members of the board are working in remote mode. Yuri Gorbachev, Doctor of Sciences in Physics and Mathematics, Senior Researcher, Head of the Research Department at Kodan Technologies. Do you hear and see us? Yes, quite all right. Vladimir Korenkov, Doctor of Technical Sciences, Head of the IT Laboratory of the Joint Institute for Nuclear Research. Do you see us and hear us well? Yes, I do. Mikhail Gnatich, Doctor of Sciences in Physics and Mathematics, Professor of the Faculty of Science of the Pavel Josef Shafarik University in Košice, Slovakia. Yes, good afternoon, I see you and hear you. And our candidate for the degree, Pyae Sone Ko Ko. We also have the thesis supervisor, Professor Alexander Bogdanov, Doctor of Sciences in Physics and Mathematics. Professor of the Department of Space Technologies and Applied Astrodynamics of St. Petersburg State University. Dear colleagues who are working in the remote mode, in order to improve the quality of our connection, kindly turn off your microphones, but don't forget to turn them on when I give you the floor. I would also like to inform you that the panel session of the dissertation board is being recorded and broadcast on the St. Petersburg State University website, and it is interpreted into English. Currently, we have an email address posted on the page with live broadcast of the board session, and all listeners can submit their questions to our candidate for the degree online. The questions regarding the thesis or scientific discussion, these questions will be forwarded to me by our technical service, and I will read them out during the discussion. Questions must be related to the presentation and the content of the thesis, and do not forget to don't ask questions about the pandemic, and do not forget to give your name and position if you submit a question. Questions that have nothing to do with the scientific discussion or dissertation will not be voiced. Under the order on the procedure of granting the academic degrees at St. Petersburg State University, approved by the local normative act, the session of the dissertation board is valid providing 2/3 of the appointed board members are present. The total number should not be fewer than 4 people. The dissertation board consists of 5 people. Everyone is with us today, including 3 members of the board that are working remotely. We have a multimedia connection with all the members of the board, as well as with our candidate. Who wrote this text? Therefore, we have a quorum. Our session should not last more than 2 hours, and the agenda is as follows. The chairman's presentation about the documents submitted by the candidate for the degree, and their conformity with the requirements. Chairman's replies to questions, if any. The candidate's presentation, providing an overview and findings of the research. Questions to the candidate regarding the presentation. No more than 2 minutes for each question. The candidate's replies to questions. Then reports on the thesis. The board members will be taking the floor in turns to provide their reviews and questions. "10 minutes per board member. Then the candidate's comments about the report on the thesis and replies to the questions, open discussion. Anyone present at the defense may state their position or ask questions about the thesis. No more than 2 minutes for everyone willing to speak. And I kindly ask you to fill in the registration form and introduce yourself before you have the floor. Then the chairman will ask the questions submitted during the broadcasting. The candidates replies to the questions, the presentation of the candidate's thesis supervisor. 5-minute discussion before the open balloting on conferring or non-conferring the academic degree. The discussion of the results of the defense will not be broadcast. Then next comes open balloting, vote counting, and recording of the results of the protocol. Then 14. Making a decision on whether to confer the academic degree or not. Candidates' closing remarks, no more than 2 minutes. So, distinguished colleagues, any questions on our agenda? Okay, no questions. I kindly ask you to switch off your mobile phones. Thank you. So, let me start the chairman's presentation. That's me. The thesis by Pyae Sone Ko Ko for the academic degree of the candidate of technical sciences, the specialization 05-1311, is titled The Construction and Optimization of Virtual Distributed Computing Systems. The thesis was approved for the defense by the order of the Academic Secretary of St. Petersburg State University, issued September 2nd, 2020. Pyae Sone Ko Ko has prepared his dissertation based on State Marine Technical University. Professor Alexander Bakhtanov, Doctor of Sciences in Physics and Mathematics, Professor of the Department of Space Technologies and Applied Astrodynamics of St. Petersburg State University, is the thesis supervisor. The list of 6 published works describe the research findings. They include 4 papers published in peer-reviewed journals recommended by the Ministry of Education and Science, and no papers in publications indexed in Web of Science and in Scopus. The candidate has submitted the full set of documents to the academic secretary. The above-mentioned documents comply with the item 12 of section 3 of the order on the procedure of granting the academic degrees at St. Petersburg State University. All the documents submitted are found in the certification file and comply with the requirements. The curator of the defense, member of the Department of the Dissertation Board Support, present here, has all the copies. So, colleagues, before I give the floor to the candidate for the degree, distinguished members of the board, do you have any general questions to the candidate for the degree? Is there a need to consider the entire list of documents submitted by the candidate? So, no questions. So, 15 minutes report, Pyae Sone Ko Ko. Please, you have the floor. A bit. So, good afternoon, dear members of the board, dear president, dear chairman, and My report is titled The Construction and Optimization of Virtual Distributed Computing Systems. In the dissertation, I consider the methods of the construction of distributed virtual computing system that allow to improve the general efficiency with the use of virtual containers, the methods of the construction of container applications, and the approach to the and the complex of programs to create the operational environment based on the containerizing technology. On this slide, you see the problems that we have in the virtual environments, regardless of the advantages of virtualization. Sometimes companies face various problems at the introduction stage. For example, insufficient efficiency and computing capacity, or very long periods of time for task resolution. And here you see the goals of my dissertation. And the main goal is to improve the efficiency of distributed computing in virtual environment. And in order to achieve these goals, the following tasks were set. On this slide, you can see the provisions brought for the defense. And on this slide, you see the methods of the construction of the virtual computing system. And here you see the two contemporary methods of the construction of our systems. First method is a method of virtualization on the basis of containers that has high efficiency of the use of hardware resources, it is characterized by low technical costs and optimization of costs for license acquisition. Second method is the method of virtualization based on hypervisor, paravirtualization, and virtualization based on host system. Using these two methods, we can construct the virtual computing system within a short period of time. Traditional virtual machines are used in order to avoid unexpected behavior. The main problem is in additional operational system adds up the gigabytes of space, and the server has problems with holding several virtual machines, and certainly the downloading is quite slow. And the containers look like virtual machines. For example, they have isolated space for launch of applications. They allow to perform different commands for root users, and they provide a network interface and IP address and so on and on. The only difference between the containers and virtual machines is that containers share the core of host with other containers. Docker container shares cores with all containers that work as separate operational system processes. It provides for the fundamental basis needed for distributed deployment of containers. And horizontal scaling becomes a goal of deployment or stoppage of several samples of each components. And Docker container provides necessary instruments not just to construct containers, but also to secure the management and the distribution between the users and hosts. And here you see several steps in order to construct the container applications with the use of a cluster computing model. First step, in order to create a Docker image, first of all, we need to create a Docker file. That's a text file with instructions and arguments. The second step is image. That's the main element for each container. After its creation, each step is cached and can be used after that. Depending on the image, we may need certain time to construct it, and thus we can launch several containers. Third step is register. The server that stores the Docker images, we can download an image and then deploy it locally and then keep it in the register. Step 4, containers are created based on samples that can open the ports and volumes in order to interact with other containers and external world, and they are easily eliminated and recreated within a short period of time. On this stage, we create the image of our container that is needed for the load balancing, and after that we will launch it on the host that we title it as Nginx container. Here you see several steps in order to construct the distributed virtual computing system using the virtual containers. On this slide, we see the Kubernetes architecture, different components of the master node and worker nodes. The master node is responsible for Kubernetes cluster management and is an entrance point. We can get connected with the master node via API. The working node is a container or a physical server that launches applications using pod and is controlled by the master node. That is a unit of planning in Kubernetes, and that's a logical collection of one or several containers that are always planned together. On this slide, you see the settings of the network. In order to have fully functional Kubernetes cluster, you should have the following things. Each pod has a unique IP address. The pod containers should interact with each other. Pod can interact with other pods in the clusters, and the application should be accessible in the internet. In order to show the efficiency of our approach, we address quite complicated goals. They work with big data, and we see that our technologies work and can be juxtaposed. And these two technologies work with big data on the container. That's an important application of container because it works with big data. That's an important task, and a lot of problems emerge, but we demonstrate how our approach helps to resolve these problems too. That's an infrastructure of distributed data. And Hadoop is and Spark is an instrument that is used for data processing, and it allows to perform different operations on distributed data collections, but it does not provide for distributed storage. And as an example on this slide, we can consider the distributed computing system that will calculate the frequency of words usage in the text. Most of MapReduce is presented by Google company. It is used when initial data is so huge that we can't compute on one container, and we should distribute the calculations between several containers united by our system. Therefore, we need a distributed computing model. Any of these two technologies could be used separately without addressing another one, and Hadoop has not just a component of data storage, but also processing component, MapReduce. Therefore, processing can be done without Spark, and Spark can be used without Hadoop because we use the container approach. And we have an opportunity to combine these technologies. And here you see the interaction scheme with the system, and for the user the system looks like a real cluster. Containers isolate the processes of one container from another and from basic infrastructure. Thus, any change in one container does not influence another one. And in this section, we provide the results of experiment and the analysis of tests. We performed the tests on Hadoop and on Spark, and also launched PageRank in a Kubernetes cluster in order to compare their productivity. We fixed the work time, maximum use of process, maximum use of memory, and we also calculated the acceleration per node. And we fixed the average time of execution in seconds. On this slide, we see the comparison of productivity of Hadoop and Spark using PageRank, and thus we can see the advantage of a joint use of these technologies. And here you see the analysis of the use of algorithms of ranging. And sometimes Spark lack time if they are used together. then the fact is better. And here you see the analysis of the use of processor on Hadoop and Spark. And we see the rise of the use of resources. And the load is nearly the same for Hadoop and for Spark. And if you use them together, the resource consumption gradually changed. In our work, we describe the methods and models that allow to improve the overall productivity of distributed computing environment based on containerization technology. The major advantage in the use of container technology is that they can be created much faster than the samples of virtual machines, and their weight provides for smaller costs if we consider productivity and dimensions. Containers improve the productivity of developers by eliminating of internet network dependencies and conflicts, and they can be considered as a separate microservice regardless of the problems with synchronization. Thank you very much. Thank you. Any questions on the report? None? Okay. Then each member of the board will be given the floor, and they will provide their reviews on the thesis, and you will answer the questions and to the remarks that are given here. And as all the reviews were already published on St. Petersburg State University website, I offered to state just basic points and comments on the thesis. So, because if everyone is going to read that all, it will take too much time. So, Professor Degtyaryov, please, you have the floor. Thank you very much. Distinguished colleagues, what I want to say about this work. As any dissertation of the Alexander Bogdanov School, it is characterized by the development of certain components in the system of virtual personal supercomputer, and this idea of virtualization of resources in order to create an efficient SMP system, virtual SMP system, that allows us to easily carry out programming and secure the efficient work of the system is found here. And the problem is how to create such a virtual system. And in this thesis, we see an attempt to develop a methodology for a person that is not a super expert in virtualization, in creating different virtual clusters and so on. Because the system is based on quite simple container technologies that are quite understandable and quite accessible to any expert that has some minimal opportunities and knowledge and skills in information technologies. So not someone completely unaware of the topic, but still. And here we see an attempt to use containers as a basis, and that is certainly less efficient than working with the development of a real personal supercomputer, but still it's easier in its components. And that is the major idea, and I believe that if it is not fully developed, but still it's quite well presented in the work, therefore I believe that from the technical point of view the implementation is sufficient, and it should be assessed positively from the point of view of the award of the academic degree. At the same time, in my review, I have certain remarks that I would like to voice shortly. First of all, the first two chapters in the dissertation, from my point of view, are a bit too heavy. And there is a lot of descriptive materials. Maybe from the methodological point of view it's not bad, but for example in the first chapter, in the end of it, we could see this question, what is the connection here with the topic of the thesis? Yet in the conclusions, the author does not give it, so you have to guess or have to be an expert in the issue. Same is true for chapter 2. If you've provided if you had an analysis and choice of methods for operational environment adapted for the needs of the user, then it would be clear why you carried out the research in chapters 3 and 4. And 3 and 4, or chapters 3 and 4, that's practically independent work of our work. For the degree, certainly there are some comments here. For example, it's not that clear from the text why this deployment of software to a Docker image is easier than a simple deployment of the virtual machine in the production environment. Though maybe that's not a question for an expert, but still you had to have this balance between a review that is needed for a person that is not an expert in the field, and still you should provide explanations for experts. And I do not mention style failures, although they are quite characteristic for PhD students for whom Russian language is not a native one. Yet I believe that the thesis complies with all the requirements, and I will vote for the award of the academic degree. Thank you, Professor Degtyaryov. Answers? Thank you very much, Professor, for the comments. I agree with your first, second, and fourth comment. And as for the third comment, I would like to answer as follows. In order to deploy virtual machines, we need quite qualified users. And creating a virtual cluster is something that could be done by highly qualified experts. Therefore, we use container technologies that are quite easier for use and user-friendly. A container file contains the rules of deployment of the applications on the Docker container. Thank you. Are you satisfied? Yes, I am. Okay, then Professor Gorbachev, please, you have the floor. Thank you very much. Do you hear me? The thesis made a positive impression. That's an interesting approach to work. But still, there are certain questions that do not certainly compromise the quality of work, but still I want to ask them. The first question. In numerical experiments that were carried out, you've selected the test data artificially. And certainly it would be interesting to look at the real data. Second point is that you don't pay too much time to the correlation of the load balancing in container. And third is that when using a container, you see the emergence of two opportunities in one core. Why do not they conflict? Thank you very much for your comments. As for the first comment, we performed a test with real data, and just real data, and one of the examples is here. The algorithm is used for the collection of documents connected with hyperlinks. and it assigns each of them the numerical definition that measures its importance and authoritative character among other documents, and the algorithm can be applied not just to web pages but to any graph. Second is that as for the construction of container applications, we created the sample, the image of container that is needed in order to balance the Nginx load on the container. Then we launch this image on host as and we described it as Nginx container. And as for the third remark, Docker containers isolate processes of one container from another one and from basic infrastructure. Thus, any change in any container does not influence another one. So, are you satisfied? Yes? And I should voice the fact that I agree with that the dissertation complies with the requirements, and the candidate for the degree deserves the academic degree. That's what I wanted to say. Okay, Professor Korenkov, distinguished colleagues, the thesis is dedicated to a relevant topic: construction and optimization of distributed virtual computing systems. And we see the use of different architecture opportunities, mostly the architecture in cloud environment, and we see the analysis of one of the popular modes, the deployment of architecture using Dockers, using the means that allow us to use such container platforms. So that's quite a popular topic today. And when we deploy containers, we may have certain problems. On the one hand, they are simple. On the other hand, how should we provide security for each container? Because there is a particular environment that's being created. And second point is efficiency, especially when we use some heavy applications. Vladimir, could you please sit closer to the microphone? Especially when we work with big data. So my comments are the conclusions of these two problems. First is that the thesis does not pay much attention to the stability of container applications and the safety from different attacks. So this safety issue. And second issue is the issue of efficiency. So we saw one artificial application, and it's hard to judge on the entire idea based on just one application if we want to think about the acceleration of work of different distributed file systems, of joint memory, and so on. So that's what I wanted to comment, that it would be wonderful to see other experiments. So the first question is the safety question, and the second question is the efficiency one. So, Vladimir, we didn't hear you in the end. Just the end. And certainly regardless of the drawbacks and that I mentioned, I would like to make a conclusion that the thesis meets the requirements of the order on the procedure of granting academic degrees, and the candidate for the degree deserves the academic degree of the candidate of technical sciences in this specialization. So please. Thank you very much, Professor Kornikov. We consider these remarks as a wish to see such experiments that I'm going to continue in the future. The major advantages of the use of container technology is that they could be created much quicker than virtual machines, and their weight provides for less costs from the point of view of productivity and dimension. Containers improve. Containers can be considered as a special microservice that could be updated without any problems with synchronization. That's it. Thank you. Thank you, Professor Ignatic. Do you hear me? Yes. Okay. So I have a simple task once again because my colleagues have already spoken out, and many things were already described and explained, and my review was also published on the website, therefore I won't go into details, but I'd like to emphasize that the main goal was to create a distributed computing system based on virtual containers and container applications. And specific result give us a complex of remote access to computing resources, and what's important is that some results of the thesis were introduced in the integration of computing resources in computing complexes, and they were used in the teaching process in universities of St. Petersburg. And I also have a number of comments. Some are the basic ones, some are essential. I'm not an expert in these issues, but when you read the work, you give one definition, then the second one, then the third one, and finally and somewhere in the middle the author writes that there is no specific definition for the term. Second point to the second chapter is that you consider well-known models in detail, models of parallel programming, and this description takes quite a lot of pages. Yet another comment is for chapter 4, where you give quite good examples of the development, but out of the examples you can't see how these developed applications resolve the problems of reliability and efficiency. And other comments are quite formal. Okay, Michal, could you please repeat what you said in the end? Yes, the last phrases. So that is the comment to chapter 4 that you missed, yes? There are quite good examples of application of developed instruments, but out of these examples you can't see in detail how these applications resolve the problem of efficiency and reliability. And certainly these comments do not compromise the overall quality of the work. And I was pleased to read this dissertation. And I would like to say these important words that this dissertation corresponds with the requirements of the order on the procedure of granting academic degrees at St. Petersburg State University. And Pyae Sone Ko Ko deserves the academic degree of the candidate of technical sciences and specialization 05-1311. That is it. Thank you very much, Professor Gnetic. I agree with these remarks with the first, second, fourth, and fifth remark. And as for the third comment, I would like to say that in Chapter 4 I give the contemporary technologies, Hadoop and Spark, that provide for high productivity in distributed environment based on the containerization technology. In order to show the efficiency of this approach, we address quite complicated tasks of working with big data, and they are quite complicated for dozens of processes, and we demonstrate how our technologies work and how they compare between themselves, how they can be compared. And these two technologies work with big data on containers, and that's an important application of the container because it works with big data. That's a hard task, and there are a lot of problems here, but we demonstrated how our approach helps to resolve these problems. Thank you. Okay, I'm satisfied with the answers. And finally, it's my turn. You know, colleagues, I did not compare my review with the reviews of other members of the board, but still, quite surprisingly, it coincides, my comments coincide, all the positive characteristics, I support them all, and can say the final words at once, that I will support the award of the academic degree. But as for my comments, before I read them out, I would like to give some personal information. On our faculty, they call me a professor and a doctor of sciences, but at the same time, each of my students know my favorite question and is always ready to answer it. And if he is unable, I won't give him any credit or good mark. So after this introduction, I would like to read it out. And the work I give a detailed analysis and comparisons of different technology of the use of parallels, but I would like to see specific recommendations of the use of these technologies, or where, in which conditions can these specific technologies be applied. That is the place in my review that coincided with the opinions of others. So there was this slide on Hadoop and other technologies. For example, if you were my student, I would ask you to tell me what are the goals, what are the classes in which you use this technology, and what are the advantages for these technologies. Do you get the question? Yes. The application of our technologies allows us to change the virtual memory and to use Hadoop and Spark at the same time, and this gives us an advantage. As it was demonstrated in the text, we used two of these technologies, Hadoop and Spark. Any of these technologies could be used separately without using the second one. And as we used the container approach, we had an opportunity to combine these two programs between themselves, as I detected. That's it. Well, I would like to continue my question. And what are the examples on what classes of tasks could these approaches be used? Could you give examples of such practical problems that could be resolved? So they are used differently, and for example, Hadoop is quite resilient if we talk about some system failures, and it provides for full restoration of, or in case of any failure and mistake. Okay, thank you. So let us continue. So I understood you offer quite well. Yes, that's what I wanted to say. Yes, okay, thank you very much. You really speak Russian quite well. When I was younger, there are people in faculty that do not like me, and sometimes they use it as, you know, some unkind words, but that's my motto now. I have a higher attestation commission diploma, therefore I say that I'm the cleverest man here. That's my diploma here. And this Professor Atsahi is a kind of motto that I use. That's not a criticism for me. So, dear members of the board, do we have any comments on this speech? No? Okay. Okay, no questions submitted via our website. Then comes the speech of our thesis supervisor, distinguished chairman, distinguished colleagues. I gave this dissertation in parallel with the previous one, and I had two goals. One goal is that I was not sure that Joseph will finish his work, and I would like to set this system. Yes, but he did. Okay. And by then it was clear that creating a system from containers is much easier. And here I mean that if we fail somewhere, we would have such a reserve option, but it turned out that it was not in vain. And I would say that what Joseph did is something that the person of my qualification can't use. That's not for professors. But I can work with containers, and in this case, that's, you know, a kind of niche, a personal niche. So I would like to say a few words about Coco. Unlike the previous work, this work was a tragic one. Yes, because at this period of time, I liked Solaris containers. And for a year and a half, I was working on Solaris containers. But then, well, we had a wonderful cluster that was made up of T2 processors, UltraSpark. They have both vector cores and superscalar cores, so these are quite powerful machines. And our feeder block got burned. We could not replace it, and he had to adapt to Docker containers at once, and I was quite, and I'm quite satisfied to mention that he was not upset by it, and certainly it's much easier to work on Solaris containers. Even I can do that. And he performed this work, and when he offered to test it himself, initially I was not sure, because he offered a kind of new insight here. And why do we like containers? When you get a machine and your processor is set, you can't do anything with it, and the container can be created as we want to see it. And when he offered that, first of all, I was not fascinated, but then I decided to give it a try, and in fact this idea worked. And why do people use Hadoop and Spark separately? Because if there are processes that require too much memory, you can't use Spark. And if you have a lot of memory but a very a slow pace, that you can't use Hadoop. So that's it. And we had this opportunity to arrange it, and Coco did it brilliantly. Therefore, I'm quite satisfied with his work, and I ask you to support this work. Okay, distinguished colleagues, now we have an opportunity to organize a closed discussion and turn off the broadcast if you believe that we need such a break. Dear colleagues, no need for such a break. Yes, it seems to me as well that And everything is clear. Let's shift to the voting procedure, and you should give your opinion publicly. So I'll take out my list. So, Professor Peterhof, I vote for. Professor Gorbachev, yes, I vote for the award of the academic degree as well. Professor Korenkov, I vote for as well. Mikhail Ignatich, yes, I vote for. And Chairman, that's me, I also support the award of the academic degree, so we vote for the award of the academic degree unanimously. And we continue. So we all see and hear each other. That's the most solving problem. And, dear colleagues, so these are quite strange words written here. I don't like the wording. Yes, I've already said 5 out of 5 voted for. Thus, distinguished colleagues and distinguished guests, I would like to announce that out of the 5 members of the board, 5 people voted for, no one voted against, and no one abstained from the vote. And the decision on the award of the academic degree of the candidate of technical sciences in specialization 05-1311 is made. Distinguished colleagues, due to the fact that our session is held in remote mode, does anyone have any comments on the procedure? None? Okay. Then the finalizing remarks. First of all, I would like to thank our academic supervisor, Professor Bogdanov. Thanks to his support, I am standing here and my defense became possible. And I would like to thank our chairman of the board and professors that took part in the defense procedure. I would like to say that I'm grateful to Professor Valentin Styaev, and I would like to thank Natalia Karpova and all our professors that that helped us a lot, and in this difficult time, risking their health, you all came here so that our defense took place. Thank you very much, everyone. Thank you very much. Okay, therefore I close our session. I thank everyone for taking part in it, and please turn off the broadcast.